Hi, today I'm going to introduce a new topic to you, graph theory. Graph theory is a fascinating topic in mathematics and computer science field. You might haven't heard it before, but it is widely used in our life to solve complex problems. Let's start it with a story of Virginia Island Kingdom. Here's a map of Virginia Island Kingdom. There are many big and small islands surrounding the core island, Virginia 1. 100 years ago, some Virginian sailor found out this unknown island nearby is full of treasures and resources. The islanders decide to name the newly found island Virginia 2 and build the first bridge in their history. 100 years later, the Virginian has built many bridges in between the islands that it discovered. And this is a graph. As you can see, the graph is made of dots and lines. In graph theory, we call these dots vertex, and the lines are edges. A vertex is the object in the graph. Usually, it is represented by the circle with a label. In our story, Virginia 1 Island is a vertex. Virginia 1 and Virginia 2 are two vertices labeled as V1 and V2. Edge is the link between vertices. Edge is represented by a line or arrow extending from one vertex to another. The bridge between V1 and V2 is an edge. And the distance between two vertices is called path. Now think about this question. After they discovered two other islands besides Virginia 2, the islanders decide to connect the main island to one of the newly found one. Can you use vertex, edge, and notation you just learned to represent the islands and bridges? How many possible representations can you draw? Hope you all come with something like this. Since they will only build one more new bridge, it can either go to Virginia 3 or Virginia 4, which are labeled as V3 and V4 here. Congratulations, you just drew a graph like a mathematician. Take a close look at the graph we just drew here. Did you see two lonely vertices that has no edges connect to them? In graph theory, we call it isolated vertex. It is a vertex of a graph that has no edges connect to it. Can you think of a real-life example of isolated vertex? Here's one. When a computer is disconnected from internet, it becomes an isolated vertex. This is a slightly different situation. There's no isolated vertex in the graph, but it's like in our Virginia Island story. If we start from V1, we can't get to V3 or V5 by walking along the bridges. So let's call it a disconnected graph. On the other hand, if we only look at V1, V2, V3, it is a connected graph. Here's a question for you. Is this graph connected or disconnected? It is disconnected, but why? Let's start from the black vertex and travel along the red edge. We can't really reach the yellow vertices. Well, you might ask, why can't I just take a left turn so that I can get onto the black edge and get to the yellow vertex? According to the definition, edge is the link between two vertices. This is an intersection, but it is not a vertex or an object in the graph. Think about a highway interchange. The two highways are crossing, but they are in different levels, so you certainly can't jump onto the other highway to get where you want. Today we talked about vertex, edge, path, and disconnected graph. Vertex and edges can represent so many things. Airports and routes, your friends and friendship, molecules and bonds. Graph theory can tell you why we only need 4 kinds to color the map. How does Google work? And many more. We'll explore these interesting questions in the future lectures.